Okay, so good afternoon, everybody. Thank you very much for attending this webinar organized by ITS, the Basque Center for Language Technology. Today we have with us José Luis Alba Castro and Carmen García Mateo, and they are going to talk about the sign language, a very interesting subject. So first of all, thank you, José Luis and Carmen, for accepting the invitation. Just a reminder that we have had already 4 webinars before this one, and we will have another one the 3rd of June at the same time. Heidi Christensen from the University of Sheffield will be visiting us. So I will start with the presentation of my 2 colleagues. It's a real pleasure for me to present both José Luis Alba Castro and Carmen García Mateo. José Luis Alba Castro is a telecom engineer and PhD since 1997 from the University of Vigo, and he now holds a full professor position in the Faculty of Telecommunications Engineering, the University of Vigo, and he's teaching image processing. But he also teaches biometrics and machine learning in computer vision in an international master in computer vision. And he's the coordinator of this international master. He's the head of the vision laboratory of the Multimedia Technologies group in the atlanTTic Research Center. He works with Carmen in this center. And his research has been focused on all topics related to pattern recognition in machine vision and multimodal human-computer interaction. He's worked in many different areas of application of computer vision, such as biometric identification with detection and recognition of faces, computer-assisted driving, medical imaging, and also automatic inspection in industry areas. In fact, he's a co-founder of the spin-off Reliable, which is a company which applies deep learning in computer vision for video surveillance. Interesting. Well, finally, he's the author of many articles and conference papers, and he's associate editor of the Jurassic Journal of Information Security. Carmen García Mateo, she's also a PhD in telecommunication engineering since 1993 by the University of Politécnica de Madrid, and she now holds a full professor position also at the Faculty of Telecommunication Engineering in Vigo. She's the head of the Multimedia Technology Group at the atlanTTic Research Center, and her research interests are focused on speech technology. And she's been working many years in the area of speech and speaker recognition, and she's been the leader of several coordinated national projects where we have been working together. She's developed technology in speech recognition, but also in speech synthesis for Spanish and Galician also. She's done quite a few long research stays as visiting researcher in very prestigious institutions such as the University of California, Santa Barbara, twice in Bell Labs, Michigan State University, and the University of Canterbury in the UK. In 2014, she was awarded with the prize Maria Josefa Bonenburger for her outstanding professional career. So it's been an honor and a pleasure to present.
Sorry, I think Inma had a problem, maybe, because he's trying to reconnect now, I think.
Okay. Hola, Germán. Sorry, I think I've been disconnected a long time.
Okay, sorry. Yeah.
I'm still reconnecting. Okay. Can you hear me?
Yes.
Yes, yes.
Okay. So I will switch off my camera. It says that I am having connectivity issues, but I don't understand why. So have I been lost a long time?
No,
I was talking
really.
to myself.
No, just 5 seconds. No problem.
Okay. Okay. So do we have Jose Luis with us?
No, I'm Carmen. I'm going to present first, and I'm going to start the presentation. Can I share the slides?
Yes.
I'm going to try it.
I think you can. That's it.
Okay. So let's start. Thank you very much, Inma, for your kind and nice presentation. In name, on behalf of Jose Luis and myself, it's our honor. We are very honored to have been invited to give this talk. It's a really nice opportunity to show what we are doing for the recent years, and also to share with you our thoughts and what we think about the future. So what we are going to talk is about our ongoing work in sign language recognition, specifically in Spanish sign language recognition, sign language. And the outline of our talks is I will be on charge of sharing with you the motivation for initiating this journey, and also to give some very brief insight into the main component of the sign language that make this problem of automatic recognition very complicated, a very complicated one. Of course, the approaches are based on artificial intelligence on machine learning algorithms, so there is need for high quality data sets. We are enrolled in several, into different procedures for or campaigns for acquiring material. So we will describe that. And in the second part, Jose Luis will describe the main technologies, the key aspect regarding the components of a sign language recognizer, and also which is the situation of our work in this area. So our background, as Inma mentioned, is mostly speech processing in any area, text-to-speech, speech recognition, audio segmentation, speaker diarization, speaker recognition for many years. Regarding speech synthesis and speech recognition, our main language of expertise is Galician. And a second area of work is image processing, where we have been working along the years in the facial biometrics, using for sure any basis, theoretical basis and tools of pattern recognition and machine learning areas. So for us, a certain moment in time was kind of easy to start to think about to moving to sign language recognition. This actually was because we started to collaborate and to talk with linguists from the University of Vigo that are expert in in Spanish Sign Language. So we started to be interested on the topic, and since we in one hand we were experts in language recognition, spoken language recognition, and also in face analysis, we decided why not? It's really a challenge, and it's let me say we were not it was not this way, but we were thinking, okay, it's not going to be that difficult. Oof, it's really difficult. We will show in a while. Apart from sign language recognition, we were been working along the years in biometrics, as I said before, on audiovisual content analysis for extracting information about people in those contents. And just recently, also we work in detection of the health, some status of like depression or stress by processing the voice. So this is our background, and as I say before, we started to collaborate and to talk with linguists, experts in sign language, and we really realized that the problem was really complex, but very appealing, a challenge from the research point of view, a good opportunity for increase our expertise and knowledge, and also, for instance, for doing PhD work, for instance. So one thing that was clear for us is the need to engage the deaf community in the project from the very beginning. So we start to talk with the Deaf Association, both at the national and regional levels. And this is really important. This was really key. Immediately, they were very happy, in the sense, very open to collaborate with us. And what they asked from the very beginning were applications. So our research has to be not only basic, but also very much application oriented. And it's very important to define several scenarios of interest for the deaf community. Also, due to the complexity of the problem, and also because we are not really a big group, it's really also necessary to enlarge the collaboration with the research community. So for that, for getting toward that goal, we participate on international challenge, not in Spanish sign language, but for instance, in Turk sign language. But it's a way to know other people, and also to get some insight in the technology. And we are also starting to organize a competition using our resources. So in this second block, just very briefly, I'm going to introduce the main component of the sign language, or the Spanish sign language, or any other sign language that makes the problem of automatic recognition very difficult. If we compare as a spoken language, like for instance Spanish, with the sign language, the Spanish sign language, we realize that for Spanish we have like 24 phonemes. That with these phonemes we will build words. And since being the problem of automatic speech recognition complicated, we don't have other components. We don't use any other components like non-verbal components, for instance, facial expressions. And nowadays, the performance of automatic speech recognizer is really good. of course, it needs improvement, especially for spontaneous speech, but the quality is good enough, for instance, for transcription. And this is because now we have enough databases for training the models, and also because we approach the problem for, let's say, continuous speech. When it comes to sign language, we have to take into account, for instance, in principle, in the beginning, the movements of the hands. So this is what we have, where we have what we call manual components. Manual components, let's say that is equivalent, not equivalent, but is doing a comparison with the spoken language are the phonemes. But in this case, we have 86 different hand configuration, 52 both palm orientations. We have more than 100 spatial allocations, 5 basic movements, several speed and repetition modifiers, and also we have to take into consideration whether the hand is touching the body or not. So we have many components we must take care of. This is just only for the manual components. We have also non-manual components that are the facial expressions and also the movement of the upper body. So from the point of view of automatic recognition, is much more complicated than that for a speech recognizer. So here is just is this a video? Yes, I'm suppose that all of you have seen people signing. Also, maybe some of you also understand sign language, Spanish sign language. Here is just to illustrate that we have to take care not only of the hands, of the movements of the hands, but also of the distance between the hands and the body, of the movements of the body and the facial expression. So it's a 3D visual language. So at the beginning, we decided, okay, we are going to face the problem, or we are going to approach the problem starting with isolated sign recognition, as we did in the past with the speech, starting with isolated word recognition. And we started to record static signs that is just an image. But the vocabulary is very short, only numbers, spelling, and also it was really not interesting for the deaf community to have an isolated sign recognizer. This was our first approach like 3 years ago, and at that time we were not in close contact with the deaf community. So from almost the very beginning, we have to start to pay attention to the dynamic signs, either built or either realized with one hand, with just one hand, or with both hands. Also, we have to count the repetition of some movements, and this is what we are now. Because so far we are not taking analyzing the face. I said at the beginning that our background was face recognition and speech recognition. I would say, okay, since we are expert with face, just completing this with the hand, with gesture recognition is enough. After 2 years, we are starting to build recognizer for the hand. So this is just an example of how difficult the problem is. Upper body movement, we haven't started yet. So once we know what we have to record, the other aspect or the other point we have to take care of is which device we should use. And here, actually, this is the last part, no? Which device we have to use. In the past, there were devices for people have to wear in order to facilitate the recognition. But also, talking to the people, to deaf people, they really do not want to use those devices. So we have decided to start recording at the database using a high quality camera, video camera, and also we use a deaf camera. Some of these two other topics are also important when we face the problem of acquiring a database. The problem of there are few native signers available compared with hearing with speech. This makes also the need of using interpreters to interact with the donors, or also to use interpreters to populate the database. Also, I want to comment with you that from the very beginning, we realized that we should also, with the researchers at our group, we should learn the Spanish sign language, not only for knowing better the problem, but also for communicating with the people that are collaborating with us. This is really important. I want to point it out, and that in our group is compulsory to learn this language. We are not really good at it. We are every week we have classes, and little by little we are progressing on learning the language and realizing how difficult it is, how rich it is from the point of view of communication, and this makes also our work more let's say more interesting. Okay, this is just an example of a summary of databases that are available for different sign language. And on the top row, there are the languages. ASL is American Sign Language. The second one is Chinese Sign Language, Danish Sign Language, British Sign Language. And here, close to the end, is Spanish Sign Language. As we see in these first columns are those languages that with more resources, and in each row we have the different devices, and more the device that is used is the video camera and the deaf device. So in this map, we can see which language are databases for, and we want, or we are looking, we are working towards the delivery of our own database this year. With video and deaf information, and with more than 250 signs. And I pass now on the presentation to Jose Luis that we will share with us the information about this database and the tools for speech recognition.
Okay, so Inma, can you pass me the control, please?
Jose Luis, I think you can just share and that's it.
Okay, let me see. Where was the sharing? Here, I guess, yeah.
We see a blank screen, white screen. Oh, okay. Mm.
See the map now?
Yes, you just need to put it in the presentation mode.
I'm in the presentation mode or not?
Now, okay. Now it's okay.
Okay. So
Okay, thank you.
as Carmen was, yeah, as Carmen was telling, this is more or less the whole map on datasets that are larger than 100 signs. So there are more, there are fewer than 100 signs. And above this number, there are a few of datasets that are also captured for continuous sign language recognition. And these in green are the datasets that are from German Sign Language. And the first one is the one that is nowadays the benchmarking for continuous sign language recognition, this one from 2014. Okay, so it is clear from this map that there are very few sign languages captured for different languages. This is American in light blue, German, Greek, Turk, Korean, Chinese, and soon Spanish, because we're collecting the database. We expected to have the database already distributed this year, but because of the pandemic, everything was very slow with the capturing. And we're also struggling with the data protection rules. So we expect to distribute the database with a contest in the latest part of this year or earlier in next year. Okay, so this is the number of Spanish Sign Language datasets that are already available. It is the first one that as far as we know, the first one was this one from Martinez Narejos from 2017. That was captured with a specific device, lip motion, that captures just very close signals. So it's capturing the hands configuration and movement. Okay, so it is captured with for 91 isolated signs, for 4 signers, and 1 signer doing sentences, 274. With RGB, the only one that we know that is the one that was collected in that study that Carmen presented. It's a very small data set. It's just signing names of 19 animals. And there's also a private data set from a startup company that is called ShowLib. They're collecting the Spanish sign language data set for their own business. Okay, so it's not available for research. And this is the data set that we are acquiring with RGB and depth. And I will comment more in depth this data set now in the next slides. Okay, so we have like 3 different objectives for the data sets. That is, one objective is to have a data set with lab conditions for research of different aspects of the sign languages. Okay, so this one is collected with 2 sensors at the same time. They are synchronized simultaneously. You can see here in the picture here the Nikon camera that is acquiring with high speed for no motion blurring, and a Kinect that is mounted on the bottom of the Nikon camera to collect the RGB and depth videos from the same point of view, more or less same point of view. We made also a portable setup for acquiring in different locations, because we have acquired in deaf associations here in Vigo and also in Pontevedra, and in the university, of course. So we wanted to do something that is really easy to transport and mount in half an hour in any place. So as I mentioned before, if it weren't because of the pandemic, we will have a much larger database nowadays. So we expect to start increasing the number in the next few months. At the same time, we wanted to have a more broadcast conditions data set. So we started like imitating the German, the weather German database that I mentioned before, that is a continuous data set of more than 1,000 signs in sentences regarding to weather report. We wanted to do the same thing with the Galician TV, because they have it's the TV station that has the larger region for the signer. So because that is something that most of the deaf people is complaining about. There is the resolution of the signer in broadcast. So this is quite well. They have take care of this issue, so that this part of the image is quite high quality and is high definition. So it is a good source to capture broadcast good broadcast conditions. So we had like 4 or 6 hours of different weather reports, like 100 weather reports, and we continue capturing this. And we have also the transcription, so we expect to do the alignment from the transcription of Galician language to this Spanish language. We have just started to prepare the construction of this database that was not planned in the original project of the minister, but we saw with the contact with the deaf people that for them it's very important to have tools in the mobile phones. They use the mobile phones a lot. They use the access to internet a lot, and they use WhatsApp to communicate each other with the video WhatsApp and this social network. So we decided to construct a mobile platform to capture these specific settings, because you know that the lengths of the mobile phones have a different field of view, so the conditions change a little bit. So in 1 month, more or less, we're going to start acquiring isolated signs in mobile phones. Okay, and with this also we expect a larger contribution from the deaf community, because they don't need to move to any place and they're very used to use their phones. Okay, so let's see in the first distribution of the dataset we can include some of these images. And regarding what kind of annotations we're doing, because we have hired an interpreter of sign language in our team, we could afford to enrich the data set with very clear annotations. So, for example, for isolated words, not much to annotate, because every file has the annotation of the word that it is, but she is annotating variations, because there's a lot of variations or small details that need to be annotated, because the people sign in very different ways. There's a lot of intervariations. For the sentences, there are more things that we have annotated. That is the start and the end of each sign. So we have the segmentation of the glosses. Also the co-articulation, the transitions between between one sign and other sign in the sentence, and also some head and facial expressivity. Mainly, we have focused on. I will talk a little bit about this later on. on negation and question, type of questions, open questions and closed question, because the movement of the eyebrows and the movement of the head is different regarding the questions if it is open or is closed. We are also annotating blinking, because there's some cues regarding the ending of the or starting of the signs with blinking. Sometimes the blinking is at random, but sometimes the blinking has some meaning. So it is interesting to annotate also this. So how is the sign language recognition nowadays in the past? So this is like a picture in these two slides. This is a pre-deep learning era for sign language recognition. So you can see that the first works on sign language recognition are started in 1983. So at the very beginning, most of the works were related to trying to detect and analyze manual components, and mainly using, because of the difficulty of doing this just with machine vision in the early 80s and 90s, there were a bunch of different devices to capture the movement. For example, electrical data globes, so that they were used in the 80s, and motion capture, just putting some marks in the hands or in the body to capture the movement. Even colored globes for helping the machine vision systems. So until the 2000s, this kind of devices for helping to acquire the hand location, movement, shape, and orientation were pretty usual, and we can call this intrusive device. As Carmen said, that the deaf community is not very happy with these intrusive devices, you can imagine. So since 2005, more or less, we starting interesting works just using RGB, and mainly since the appearance of Kinect, Microsoft Kinect in 2010, we have seen a shift to just using RGB or RGB plus depth or just depth. And even in this late 2010, 2012, when convolutional neural networks start to show their powerful capacity of extracting visual information, then we have seen like exponential number of works regarding using RGB, depth, and deep convolutional neural networks. And in 2014, this German group, very well known in the translation community, they launched this benchmark on this continuous language database for German. Okay, so this is more or less the picture before 2015, and then from 2015 up today, we can call this the deep learning area. So the most of the systems even for extracting features from hand configuration and movements started to be done just with convolutional neural networks. Okay, so the CNNs applied, as I said before, directly in the RGB input or the depth input or combination of both, or even very soon, because sign language recognition has been fed by different approaches that were really good for action recognition. Okay. The sign language started to work also in body and hand joints. So as I mentioned here, these advances in other fields, and that were also advances because of deep learning, could be leveraged for sign language recognition. So from the 2015, we can see that human pose estimation in the wild without extracting background, foreground, etc., can be used for with very success in action recognition. So even when action recognition is not exactly the same problem as sign language recognition, it's clearly sign language recognition is like a subset of human action recognition, but with specificities that made it very complex in detailed actions because of the movement, the rapid movement of the fingers and hands, and in parallel with the face expressions. So we could see also some advances in video action classification with spatial temporal feature learning using convolutional neural networks combined with recurrent networks like long, short-term memories, recurrent units, or more recently, since 2 or 3 years ago, we've seen also interesting progress in different type of convolutional neural networks that are the graph convolutional networks for skeleton dynamics. So we see that using image processing for extracting pose of the person, the joints of the people, we then can get rid of all the texture information and just use graph convolutional networks for learning the spatio-temporal changes in sign language or in actions. Okay. More recently, even 2 years ago, attention networks and transformers started to be used for translation. Yeah? We need to do the distinction here in this presentation from sign language recognition and sign language translation. Okay. Here we are dealing just with sign language recognition, and most of the work we have done so far in University of Vigo is for isolated or word-level sign language recognition. So we just started to scratch the problem of translation that is more related to sequence encoding and decoding. Okay, so the works on sign language recognition, continuous sign language recognition and translations are mainly done using this type of neural networks that probably most of you know very well, transformers for translation. Okay, so we see also that since 2018, we start to see different languages acquiring data sets. Right? So I've seen that it's very bit late, so we're going rapidly with the work that we have done in the University of Vigo. This is the current technical activities in the project aimed to sign language, Spanish language recognition is can be separated in these more theoretical studies. So if segmenting body parts versus not segmenting using the RGB frame, if we can afford not segmenting the body parts as it is the trend with deep learning. What about depth information? Do we need depth information, or we can estimate depth directly from RGB? And what about the frame rate and the shutter speed? Did you have here an example of exactly the same frame, well, in the same moment, but from the Kinect that is in the right, from the Nikon. So this is not a very drastic blur, but there are more examples with more blurring. Okay, so if how much motion blur can we deal with. So that kind of information and all the results of this investigation is important to decide how parameterized are recognized for real time on mobile platforms. Okay, so we need to be careful with the computational burden in the mobile platforms. I've also made some work on detection of head and facial expressivity just for communicative classes, not related to emotions, not related to the classical sad, happy, etc. But as I mentioned before, to detect the negations, interrogation, etc. And we have made also some work on deep models for word-level static and dynamic signs, and we're starting to study the scalability of this problem. So very rapidly, this is the work that we have done to co-register the Nikon images with the Kinect images, so we can take advantage of the depth information captured by the Kinect and transfer that depth information to the Nikon. So we can use different sources of information to have a good segmentation of the hands and the face. Okay, so we passed this example to a group of deaf people to see if they were able to understand the message just using the segmentation of the hands. Okay, so we show them this video, and then we show the same video using also the expressivity. Okay, with the video in the left, just with the hands, they wouldn't able to understand the whole message, but with this video they understood the whole message. But it's also true that for some other videos they need to see the body, because as Carmen mentioned before, there are some signs that are discriminative just because of they touch in a specific way in some part of the body or some part of the arm. So maybe this is a theoretical work that is worth it, but just to say that using full frame with the powerful of deep learning, it will be a much better approach. Okay. Regarding the study of the expressivity of the facial expressivity, we can see here an example of negation, an example of open question, and an example of closed question. So the movements are different. So we try to make a classifier of different type of interrogations here. This is partial, and negations. Okay. Just using key points, 2D key points from face masks. Okay, so you can see here that with these key points, we can see where the eyebrows are, how are they moving, etc., blinking, lip separation, etc. So with just this 2D information and in time, this is the best classifier accuracy that we have. So we need to improve on this. So we're just working this and working also on including 3D information from the face. Okay, so you have here another study when we have used for face expressivity a 3D model. This 3D face, I have a last slide with the references. And for the fingers and the hand, we have this model that is feeding from a parametric model of hands. Both of these models are quite complex, so it's difficult to fit exactly the specific parameters that are better for the specific problem of sign language recognition. But at least it seems that the accuracy, even when there's some occlusion, is good with this model because it's a parametric model that has a lot of prior information. And then the last part, and with this I finish the presentation, is there's a couple of slides explaining what we have done regarding modeling word-level models or sign language recognition. So we applied for this competition that ran a couple of months ago. This competition that will be presented in a computer vision and pattern recognition workshop. And it was launched with a new data set that was launched in January this year. There is the Ankara University Turk Sign Language data set. And this is not a very large data set. It's comparable to the data set that we have, but with more samples. So it has 226 signs and 43 signers. So this is more or less the statistics. And this is an example of the scenario. So they have recordings indoors and outdoors. And this is one example of the open pose key points estimator in this specific image. So we have used open pose for extracting scalar information. So we have developed a comparative work using state-of-the-art RGB-based models versus skeleton-based models. And the results were quite interesting. This slide presents the RGB-based model that we have used. There is some efficient inception 3D convolutional neural network that is more efficient than the classical I3D that is using also special temporal convolutions, because this separates in space and time the convolutions. So this is the main building blocks of the 3D convolutional neural network, and this is a typical inception block, but separating space convolution and time convolution in this case. So in this case, the model was pre-trained with a data set of human actions. As I mentioned before, human action is a very good source of information from code and theory for sign language recognition, of course, and was afterwards fine-tuned with the data set of the contest, the Turk data set. Okay, so we restricted the length in time to 2-3 seconds. There's more or less the time that the signers used to do the signs. Okay, and this is the result. This is the baseline that the organizers of the competition prepared using their own results from the presenters of the data set. So this is the baseline over the same data set, and this is the result that we have with this state-of-the-art RGB-based model. So it's much larger than the baseline, of course. Okay, but not enough to win the competition. So we tried another model that is quite promising. That is a spatial temporal graph convolutional network, and I can explain this very quickly just looking at this picture here. This is a classical spatial and temporal network that try to learn, for example, for this node, where the spatial neighbors and the temporal neighbors that are potentially related to the behavior of this node. Okay, then you can have cross information between different points in space and time, and then you have this multi-scale graph convolution network that we have used for this competition, that tries also in a multi-scale approach to decode the information that is related to one node, even if the node is far from other nodes. So this is important for, at least the key for the success of this model that was prepared for, not for sign language recognition, but I think we were the first one to use it for sign language recognition, because we have seen that there are a lot of symmetry and a lot of interdependency between movements of one hand and movements of the other hand, and maybe even the tip of one of the fingers in one hand and the other. So even when in the graph there are nodes that are very far apart, with this multi-scale approach, we can find the relationship between one node and other node in time. For many signs, that is quite important. Okay, so we did this approach that is extracting the key points, extract the features of the key points. That is just the coordinates and the confidence of the key points extracted from this part here. And we extract the normalized information for the joints and for the bones. So the segments that joint every two joints, okay, bones. And then we just train two different multi-scale temporal graph convolutional networks, and we add and fuse the results, and we have the prediction. So we use this for the contest, and you have here the comparison between the joints, bones, the motion joints. So it's the difference with in time with a different in time and different frames for the joints and the bones, and the fusion also with the S3D. So we have all the combinations here, and we can see that the conclusions are quite interesting. That is, that this type of models perform better than the RGB-based, at least in our tests and in this data set. The fusion of the methods improves the performance slightly, but increasing too much the complexity and training times. So you can see, for example, that just using joints and bones, we have already 95.7, and we can reach a 96.15, but using also the S3D. With this model, we got the fifth position in the challenge. The first one that got 98.4 was a combination of a lot of different RGB-based skeleton-based approaches. So it's computationally very, very, very expensive. Okay, so we think that this is the way to go. And the last thing that we do was trying to see if the Spanish sign language was not represented in the contest, because we used this Turkish sign language. So if the Spanish sign language that we had acquired could be also trained with this kind of models, because we have a much less number of videos than in the data set of the contest. What we did was for transfer learning from what we have learned from the other data sets. So we tried another data set that is in American Sign Language with 2,000 signs, but with a domain that is completely different from a lab scenario, that is videos from YouTube. We try, of course, the same data set in the context that is quite similar to our scenario. So it's semi-lab conditions captured with Kinect 2. So it's very similar to our data set. And what we have learned is this, that with this multi-scale graph convolutional network, if we train the model with our small data set, just using the 40 signs, isolated signs, not using the sentences, is not enough to capture all the variations. So using 27 signers, different from the 5 test signers, we achieve with joints this number, and with bones this number. Okay. But just pre-training with the very large data set, the American Sign Language data set, so it's another language and another domain, we got 93 and 95 respectively. But even more interestingly, if we just pre-train with a data set that is much smaller than this, but with similar conditions, we could obtain in our data set 97 and 98%. So the lessons learned here is that somehow it doesn't matter that a specific language is under-resourced. If you have enough information to capture the special temporal dependencies of the movements, that of course there will be some movements, some configuration of the hands that are proper for specific languages, and of course the translation is totally different. But at least for capturing the information of the configuration of the hand, the movement of the hand, the position of the hand, and touching or not with the body, etc., etc. Just a fine-tuning with the under-resourced language could be enough. So now we have to see if the scalability of this result is true or not. So these are the papers that we have used and code that we have used for this presentation. Okay, so I think that this will be recorded, it's been recorded, so you can check the information here. So that's all. Thank you for your attention. I'm sorry for the extra time questions.
Thank you very much, José Luis, and thank you, Carmen, for this very, very interesting and so nice presentations. So now it's time for questions, and I think, oh, great, we already have hands. So I will give the hand to Horacio. Let me find you. Okay, Horacio, so you can talk. You can use your microphone. Oh, great.
Yes. Hello. Can you hear me?
Yes.
Fantastic.
Clear.
So, thank you, Carmen, and thank you, José Luis, for the talk. First, I have one curiosity and then a few questions about the data set. So the curiosity is whether you will also work on Galician sign language at some point. And then for the data set, I wonder if the domain of the data set matters, and with respect to the notation, whether say every sign will be the sequence of signs will be translated into glosses. Is that the data set? So the videos and the transcription to glosses as well? Thank you.
Yes, for the first question, Galician sign language is the same that Spanish sign language. So they're like in different local areas, you can have signs that are different, but they're just related to specific signs. So the grammatics and the most, I can say 99.9% of the glosses are the same in Spanish and in Galician. Okay, so in that sense, we're not making any difference. Well, in the annotation of the data set, we can just sometimes put, so this is a variation that is not very typical, for example, in Madrid, or for saying. Regarding the other question, so for the sentences, we're annotating the glosses. And the idea is that we will start now with continuous sign language and trying to do the sequence-to-sequence translation already using. We're starting to use transformers, but we don't have any results in our small data set, so we wouldn't put this in the presentation for today. I don't know, did you mention anything else?
Yeah, for the domain, so is there any particular domain that you address? I mean, there is the example of weather reports, but for the corporate release?
Yeah, we ran a survey in the dev community. So we made the questions of what is the specific domain you would like to have a potential service like this. And the first domain was the health domain, the medical situation when they go to the hospital and they had to go with an interpreter. That is a situation that should be more private for them. So that was by a large difference was the first. The second was the bank domain. It's also the delegate going to the bank and talking about their money and and then situation regarding use the mobile phone, going to the shops and ask questions and use their mobile phone for asking and responding questions. So what we did was starting the sentences. We have 90 sentences related to the health domain. So we have selected 90 sentences just related to I have a pain in my neck and what we should do. Or last night I couldn't sleep because I'm nervous, blah, blah, blah. So we have we started with that. So we have recorded like already 10 people with 90 sentences, and that's the part that is more stopped because of the pandemic. So I wanted to increase that now. But yeah, it's very important to have a domain. So in lab domain, we will have the first domain will be health, and in broadcast domain, we stick with the weather information because we're replicating the Phoenix weather dataset. Okay.
Thank you very much. Thank you.
Yeah, we have another question from Eleftherios.
Hi, I hope you can hear me.
Yes, we can hear you.
Actually, I have two questions. The first one has to do with glosses.
Sorry, I can't hear you. It's very, very, very low.
So the first one has to do with glosses.
Can you hear me better now? I'm speaking closer to the microphone.
Yeah, a little bit better.
Okay, so my first question has to do with glosses. So like how happy are we with glosses? Whether the annotation of glosses at the moment is enough to express the language, or maybe it's better to aim to translating directly to text, long text, full text like sentence. That would be my first question. And if I can say my second question, in the German Sign Language, lips are very important because many words are spoken with lip movements. I don't know if you have seen any work with that. How is it in your in the Spanish language? And yeah, like if you have any comments.
Okay, regarding the first question, it is very, very difficult. That's why we hired an interpreter, and now the interpreter is asking us to hire a deaf person to annotate the glosses correctly. There are a lot of variations, but we, as far as we understand, that is the best way to do it. There's a clear annotation. I hadn't thought of using, if I understood your question, sentences for the glosses, because the linguistics have glosses and they have a clear definition. Even with the variation of the glosses and the execution of the glosses, they know that is a gloss. So I don't know what's the advantage of using a sentence for the or you mean end-to-end sentences? A sentence in sign language and a sentence.
Yes.
Yeah, but I guess that would increase exponentially the number of material that you need for training. So that's a problem. And the other question was, sorry, what was? I forgot the other question.
About lips, like lip movement.
Lips movement.
Yeah. I don't know in German, but in Spanish, it's true that the lips are used for the lips and the teeth are used for expressing, like augmenting, for example, a meaning, like doing some specific noises with the lips and doing or but we're annotating just the eyebrows and the head movement and blinking, but we are not annotating the lips.
Actually, if I can intervene, there are some regarding the lips. There are some deaf people that use also lips for reinforcing, because some of them they have cochlear implants and they can replicate the words. So it's like a reinforcement, but it's not the general situation. And so far also we haven't tackled that problem. We know that lips reading can be used as an auxiliary channel and can be of use for increasing performance. But so far, no, we are not annotating that. We are at the beginning of being aware of that problem. We just learned last week, for instance, that sometimes when they have just a sign for a specific concept, and if there are variations, then they use the word from the spoken. They borrow the word from the spoken language to reinforce the sign, because the sign could be very too generic. But we are not. We are aware of that, but we are not tackling.
Yeah. When we started to decide what type of information to annotate, because it was so much effort, we prefer to stick to things that are more well known in the community of interpreters and this problem. I remember talking about this problem with interpreter of mouthing, and she said that is very, very difficult, because some people discuss mouthing because it's an automatic brain process, and they start just moving their mouth and doing sounds, but with no relation, apparently no relation to the message. So it's very difficult.
Thank you. Eneko, it's your turn. You can use your microphone. We have so many questions.
Yeah, hello. Thanks for the great presentation. I don't know much about this field, so I'm not working on sign recognition, but I was excited to see so good results. Especially, I like this part where you could transfer parts of the things that you learn in some datasets to other datasets. I think, well, that is something that we are seeing in deep learning, in other phenomena as well. So I think that's very promising. And in this sense, I wanted to ask whether all the large data sets, whether they are compatible. I mean, I saw that you did transfer between some data sets in your last slide, But would it be able to pre-train on the rest of the data sets in all the languages, and then apply the model and fine-tune it to the actual final data set, or are they incompatible in the sense that maybe the annotations or the pre-processing or whatever is different?
That's a really interesting question, because we, in fact, do the pre-training with the WL-ASL dataset, that is 2000 isolated signs, and the dark dataset, that is 256, and with both of them at the same time. Okay, so what I didn't put the result, but using the larger dataset and the shorter dataset that are from different domains, because one was from YouTube and the other one was for semi-lab, didn't improve anything the pre-training with the shorter dataset that was more similar to our domain. So I think one important thing is to select a dataset that is in a similar domain to your final dataset that is under resource. And next, if you don't have that, having a lot of information from another dataset, okay, it will be a larger trainer, but it's less efficient, but it's better than starting from scratch. That is what we did also with our dataset. We would like to try with more datasets with other languages and do a job on just crossing domains and crossing datasets and see if we have some lesson from that.
Thank you. Very interesting. Thank you very much.
Thank you, Neko. So now Thierry Declerc. Okay.
So yes, thank you. Thank you for the talk. The camera is not. No. Can you hear me?
But we.
Yeah,
yes.
We can hear you.
Okay.
Yes.
Yeah, many thanks. A question to Carmen. She spoke about 86 hand configuration, 52 palm movements, and so I am very interested if there is a list, what kind of structured list of such features and the possible values it can have. So do you have such a list that we can see all those 86 hand configuration?
Actually, we borrowed that information from the linguist. We can ask them about if they have any manuals or are you asking about how these configurations are and all of them?
Yes.
We have to talk to the linguist because we borrowed that information from them. We are learning as learners, as beginners of learning sign language, Spanish sign language. We realize that are a lot of them. Many of them we were not thinking about at the beginning. It's very, very, very rich. But we can, if you can contact us, we can ask our colleagues about a good tutorial, a good manual for that information. I know that they are.
I would do this with a good pleasure. I'm interested in collecting data categories for different types of languages, and this looks very interesting. So I will write you a mail.
Actually, when we start this collaboration with the linguists, it was both in both directions. They are working on the normal standardization of the language, on the normalization of the definition of the glosses. It's an open problem yet. So it's something that many people are working on.
Great.
Yeah, there's a web page with a data set of 2 persons signing different configurations and different locations. I can look for it because I know I have somewhere. So it's quite visual. Okay. So
it would be great. I will send you a mail. Thank you.
Okay.
Great. So I think it's already time to finish this wonderful presentation. So congratulations for your work, and thank you very much again for for this talk, both José Luis
Thank
and
you
Carmen.
for inviting us.
Yes, I don't know if the big applause.
Thank you.
I don't know if Eneko wants to say something. You can.
No, just say
okay.
thank you again, and it's very kind from you to take part in this webinar series, and I hope we are in contact later on.
Sure. We just, I think we all share we all agree that sign language can be considered as any other language. It's a visual language, but it's a language, and it should be included in any program promoting language technology, also as a minority language as it is.
I had a question about that. So how big is the community? But I think that we can discuss this in private because the time is over.
Yeah, it's not as big, but it's really important because a theta person is the way. For some of them, is the only way for communication. So it's important to develop technology for them and for us to be able to communicate with them in both directions.
Yeah, there are like
definitively.
70,000 people that use Spanish Sign Language.
Okay.
Around 70,000 that use it as the primary language, and 100,000 that use it just every day in Spain.
Wow. Good. So thank you very much again.
Thank you.
And we see each other in the next. I have here the slide for the next next presentation, which is going to be on June the 3rd. Heidi Christensen from University of Sheffield. She's going to talk us about speech technologies again.
Okay, thank you.
Okay. Bye.
So,
Thank you.
Bye-bye to
Thank
everybody.
you all.